Hi, my name is Arden Thomas. I'm the Cincom Small Talk Product Manager. I want to talk to you today about a framework called MatriX. And MatriX is a simplified concurrency solution that lets you easily use concurrency and get the most from your multi-core processor. So how did MatriX get started? Well, MatriX was started as a product management challenge to our engineering team to develop a solution to leveraging multi-core computers. We recognized that it was pretty much impossible to buy a new computer that wasn't multi-core. Now, MatriX is the second generation of this solution, and it grew to include remote machines so it can be used as a grid solution as well. What I really like about MatriX is that it has a very easy to use, simple, powerful API, and I'll show you an example of that in this. What a lot of people don't realize is that most applications do not use multi-cores. So a lot of times if you have, say, a quad-core computer, you might have a lot of idle compute power available to you that's not being used. Now, you can build very sophisticated concurrent applications with our products. We have all the tools and abilities with distributed Smalltalk and STST to do very complex, very sophisticated applications. Of course, doing that is a lot of work. It's not trivial. Certainly, as the power of using concurrency goes up linearly, the complexity goes up exponentially. So what MatriX is a simple way to get a big bang for your buck by using concurrency. And we like to quote Pareto's law of you get basically 80% of the benefits with 20% of the pain. So MatriX is not a panacea. It won't solve every problem. It can't use it in every scenario, but it works in a lot of situations, and where it works, it tends to work very well. It's a very simple, pragmatic solution, and lots of our customers are reporting back they're getting 2 to 5x performance improvements by using MatriX. So let's go to a code example. Here's a method called populate, and this gets a lot of unique keys and then does some work through a collect iterator. So this could be representative of going through all the customers in your database and doing some work. So the actual code here, the populate colon, does this. It creates a new stock with the symbol. So this is like a stock market stock. And then it loads the data from the internet, and it saves the data out to the hard drive. So it's representative of taking some time and doing some processing. And then it returns nil. So the MatriX solution to doing the exact same thing, and this is what I really like, has one new line of code, and you see that in bold here. The VMs gets virtual machines new, and I tell it how many virtual machines I want it to create to do this processing for me. And then the next line is slightly modified where I tell the VMs to do the same work that was being done before in the linear solution. And that's all I have to do to make this a concurrent solution. Well, let's look at the time results. So the time to run it as a linear solution took 679 seconds. If I ran MatriX with 4 virtual machines, it dropped that time down to 201 seconds, which is over 3 times faster. And if I ran 8 virtual machines, it took 131 seconds, which is over 5 times faster. And this is what we really like about it. With such minimal coding changes, you get some pretty impressive boosts in performance. So the takeaway we want to leave you with MatriX is make sure you're using the full potential of the hardware that you have probably sitting in front of you, and this allows you to do that. We'd like you to, if you're interested in this, get more information. You can watch a more detailed video about our multi-core solution, or we recommend you try it for yourself at try.cincomsmalltalk.com. If you have any questions, suggestions, comments, please contact me at athomas@cincom.com. Thank you.